Hello, everyone, and welcome to the workshop. Today we have a guest speaker from TechIntern.io. His name is Wang, and he is one of the co-founders of the company. Their main goal is basically connecting students and new graduates to companies like tech companies and their internships and whatnot. So kind of like rather than you having to go and applying everywhere, their goal is to really streamline that process. And it sounds really I've looked some at it. It sounds really cool. But today in particular, we're going to be focusing mostly on he's going to be running through different fields specific to tech and stuff. I am very excited for this just because if you've one of the big things, for game development specifically, one of the big things if you're looking into a bigger company is how when you say if you're applying to the company, if you apply to a whole bunch of positions with game design and then the game logic and then also the backend, they're going to look at that and think, oh, this person's not focused. And they will either just look at you for one of those positions or they'll just ignore you. So especially if you're trying to go into a bigger studio, it's good to know what you want to focus on. So that's not to say you need to pick something and stick with it for life, but it's good to have an idea of what's out there and what you think you would like to get into. So this feels especially, useful in that sense, but also just, there's a lot out there. So this should be useful for that. I feel like I've probably forgotten something, but if I have, feel free to let people know, but I'm going to pass it off to you, Qile.
Sounds good.
Yeah, floor is yours.
Thank you very much, Daniel. Appreciate the introduction. Glad to be here, and really appreciate the opportunity to really just talk about things that we're working on, and some of the insights we've come along in the process of connecting with tech companies as well as being in the industry. So I guess before I begin, just to double check, can everybody still see my screen? Because I can see this screen sharing is paused.
Yeah.
Right now.
Yeah, we can see it.
All right, cool. Just want to double check, make sure we're not doing the Zoom kerfuffle here. Starting off with the slide, with the agenda. So I'll start with a background overview of what TechIntern is, and some of my background in terms of how I'm getting, how I've learned about the things I'm talking about right now. I'll give an overview of some positions, some of the common positions that I've seen in the industry from myself, as well as from the perspective of our corporate partners, and then some deep dives into some of the skill sets these positions usually have, and the specializations that career paths that usually take you there, as well as some examples of their work. I also give some work talking on other career considerations, as well as some less common specializations that still warrant a shout out by themselves. And then after that, we'll have some Q&A. Although if you have any questions during the process, feel free to put them in the chat or wherever in the Discord, and I will try and answer them as I can. So for some background on myself, as Daniel mentioned, my name is Qile, so the Q. I am one of the co-founders of TechIntern.io. Essentially, what we're trying to do here, what we do at TechIntern.io is we are trying to build a co-op program or a work-study program that's not attached to any particular university or institution. So we'll do all the legwork in connecting with companies, mostly startups in our network, and asking them for any internship positions or new grad positions with a focus on internships. That if they're looking to hire or students for the coming term. For students, the process looks, once we have that list of opportunities, we'll open up applications to students around once every month, with our next round coming in the weekend of April 2nd to 6th. And for students, students during that period of time when its applications are open, we they offer a one-click application process. So for every opportunity you're interested in, you click one checkbox, and at the end of selecting all your opportunities, you click a button to finalize your selections, and that's it. Afterwards, the companies will reach out directly once we sent the resumes out with your information to the companies themselves. All the application opportunities we have are free. Sorry, the entire process for us is free, and the opportunities we have are all paid. For my personal experience, I'm a recent graduate from the University of Waterloo, and some of my past experiences in the industry include working for companies across startups, from Y Combinator startups to mid-sized startups like LeafLink, or large startups like Uber, and also doing consulting and contract work just on the side myself. So that's a bit of the background, so where I'm coming from and the kind of experience we're working with here. And now we can move on to an overview of the positions that are common, and there are eight that I put down on the slides. But although this is by no means an exhaustive list, the first one that I want to go over is front-end engineering. So front-end engineering, on a high level, is mostly engineers that build things that users can see, and when you think about front end in the industry terms, most often a hiring manager or recruiter will assume automatically that you're talking about web interfaces. So mostly websites or things that can be built with JavaScript, HTML, CSS, and other scaffolding-based languages, which are the most frequent skill sets for these engineers. However, as I've mentioned here, you're not limited to strictly web style work as a front-end engineer, because there are a lot more applications of JavaScript and that similar tool set beyond just building websites. For example, Discord, which you might be familiar with, is built with Electron in React Native, which is a framework that uses JavaScript as core in order to build web applications that can be used on the desktop. Same goes for Slack, or a lot of the more of the frameworks that are look very similar between web and desktop. The next stuff I want to talk about is backend engineering. So backend engineering is more of a general catch-all for non-specialist software development. So the really core of that is building things that the user doesn't see. For backend engineering in the industry, you might see a lot more often as a specialized job title on small companies' websites rather than large companies, because in large companies like Facebook, Google, or so forth, they usually hire for 3 different types of engineers, with the general software engineering track just being assumed that you have a backend engineering skill set. I can talk a bit more about the differences between large and small companies later on in the workshop as well. For the tools of backend engineering, because it's so general, they come in all sorts, from working on deployment system. There's no dedicated deployment engineer, or scripting languages like Python or JavaScript or Golang or Rust, and the role really varies a ton depending on the size of the company. For example, I personally worked as a backend engineer / full stack engineer, which is full stack meaning just front end plus backend combined, and a lump sum role myself for our multiple internships. I believe 5 of my internships were unofficially backend ones. And I've worked in everything from building out a webhook system to building emails to wrangling data warehousing infrastructure, and so forth. So there's a lot that goes on there based on whatever you want to specialize in. Next up, speaking of infrastructure and deployment systems, we have infrastructure engineering. So this specialization is building the infrastructure that engineers rely on. So an example of their work comes from, think about when you're writing code and the process of putting that to somewhere that people can see. For a game dev perspective, you need to compile the game and make sure that the executables are sent to people who actually have the tools to run it. Or for web frameworks, you have to make sure that you're putting on a server that's open up to the web, so people can actually navigate to it from their browser. That's what infrastructure engineering is for. They're building the frameworks and the systems that engineers use in order to really streamline the development process. So not everybody has to care about all the small steps between them writing their code and actually getting to where that code is being used by the end consumer. Some of their tenets include ensuring that systems are reliable, scalable, and resistant to failure, which is really the main things you want to aim for any business need that you're meeting as an engineer. And the last point here is, like I mentioned, they're trying to reduce the time spent building solutions to common problems. So if you need a database, that's a pretty common use case. You don't want to be building out a new database every time you're building new projects. That's related to the other project you've done in the past. You might have scaffolding, which is what infrastructure is there for. Next, last one on the slide. So part one slide is almost done. Is data science, and data science is also a generalist role in the way that backend engineering is, except it's much more statistics based, and is more in the domain of analysis. It's a generalist role for finding valuable insights from collected data. So, for example, if you're let's say using on Twitch with the search engine example, if you searched for this stream in the past, you're probably going to want to search for that streamer sometime in the future, or show recommendations for streamers similar to them based on the time that you're spending on different locations on the platform. So data science is creating projects and algorithms and other similar systems in order to extract programmatic value from the information that I already have. Some of the examples of the work they do include working on data pipelines. So processing data from just the raw input, for example, your mouse moving around different parts of the screen, to actual insights, saying that okay, this person spent 3 minutes with their mouse hovered on the screen, and then and then afterwards, when the streamer said to move to a different area, they had to click around, so they might have been confused. And that's the insight that we need to make our user interface more intuitive and better to understand. Yeah, data modeling, which involves converting the data from one domain to another. For example, combining two different types of data from the user clicks to user time on page, and making sense of that to a certain model. Visualizations, which is just putting into more well-explained terms and visual terms of what things are going on, and other just ad hoc investigations based on most of the statistical knowledge that they are expected to have. It's definitely more math and statistics heavy compared to the other engineering roles, because you have to use things like gradient descent analysis, and a lot of linear algebra and calculus involved in your day-to-day job, depending on what kind of company you're in, and mostly the size of the company, because these roles, like I mentioned with backend, all vary tremendously based on the needs of the business, which differ based on company size primarily. Because Google is going to have very different problems than you trying to launch your own website. So that's the first slide. Does anyone have questions before I go into 4 more specializations?
Can I interject a couple points?
Sure thing.
So on the note of infrastructure, that I think could also include, like, for game development specifically, there's a role called like tools engineer, where say you're building like level editors and things, things that don't necessarily end up in the final game, but the entire team is going to use it all the time. And sometimes level editors do get shipped with the game. It's pretty cool when that happens. And then data science also is important. Like if you're working on League of Legends, there's a lot of data that gets generated with every game of which champions are good, which are bad, that kind of thing. So that also could tie into like balance and things if you're into more like competitive stuff.
For sure. Like one of my friends worked as an infrastructure engineer for Riot while they were migrating their servers from the West Coast to Chicago, and that was a whole story that I can go into in the deep dive. And also data science. I know a few people who are still data scientists at Uber from my past employment who are working on things like, okay, how much do we price this ride? How do we dynamically adjust the pricing based on the current trends, or how do we move drivers from one place to another to make sure that there's always enough people getting to places? So there's a lot of different applications there that you could totally explore based on what the company needs. Cool. So so moving on to the next set of four, we have mobile engineering, security engineering, product management, and UI UX design. Mobile engineering is very similar in this role to front-end engineering, except it's really specific to mobile devices because the tenets that are used in and mobile engineering have some very deep specializations and are common enough that they warrant having specialists that aren't just called front-end engineers. So basically, here I'm mostly talking about iOS and Android because the other frameworks do have a lot more cross compatibility with front-end engineering skill sets. However, the skill sets definitely are transferable to a lot of backend and front-end and other infrastructure engineering and some of the data science as well, just because the core tenets involve manipulating data and moving them in ways that make sense for the business. I can go into more detail in the deep dive itself. For security engineering is a very special domain within the field of technology, just because the pathways to security engineering differ a lot from the other engineering that you can see in backend, front-end, infrastructure, data science, mobile engineering. It's really a catch-all term for roles that deal with network security and networks engineering in general. And it can involve a lot of different things, from penetration testing to white hat hacking to corporate security, and so forth. It could also be a part of the role description for an infrastructure engineer, and vice versa, based on the type of company. But I wanted to give it a shout out because it is such a unique part with its own distinct culture within technology. There's a high bar to entry, but experts are always extremely in demand because the cost benefit ratio for a company hiring an expert versus not is so high. For example, Equifax breach, the Sony breach, or so forth, that it just makes no sense not to have experts, and nobody wants a beginner. So you have to really fight for your role to prove your credentials in order to get in. The reason why I'm saying it's a very unique role within technology is because within the other engineering aspects, there's a lot more flexibility for newcomers, and there's a lot more openings for for beginner positions. But with security, there's a lot more specific certifications that are a lot more valuable. For example, there's some of the common networking switches that are used around the world include Cisco or IBM networks, and you can be domain experts within Cisco or IBM, and you need certifications for that. Otherwise, people won't trust you to actually work as a security engineer, and that's like an added barrier to entry on top of knowing that you have technical chops and experience. So next up is more of the less engineering focused side, but two other common specializations that are very much in demand within technology, which are product management and UI UX design. Product management is the voice of the customer in deciding what to build and when to really build it. It's a really cross-disciplinary field that you could be technical or you could not be. But it involves working with business, engineering, and design, sales, marketing, and the entire gamut of the organization, depending on what kind of products you're building, in order to deliver value and make sure that your work is valuable to the customer at the end of the day. Okay. Again, it varies a lot based on product stage and company size, but if you're looking for a position or a career path that really really gives you more high-level organizational control over wherever you're working, product management might be for you if you don't want to do technical engineering management. I've seen a lot of my friends personally make the transition from being an engineer, be either front end or back end, to being a product manager, and they have technical experience in order to be a better product manager or a manager because of it. So there's a lot of specializations within that as well. Next up is UI UX design, where you're creating the interface of the product for engineers to implement. And there's a lot of different processes involved in getting to a design, notably ideating not just the entire interface, but also the entire visual and the user experience. Because the flow from when, for example, with Amazon, if you're going to be the entire experience from when you're going to the website to when you check out is something that can be designed and curated to make more value for the company and for the user. It varies very heavily depending on the company structure. Some larger companies have a lot more design systematic approaches where they make you do a certain amount of X, Y, Z before you can validate that your design is worth using, or you can be working more a small company and startup resource strapped environment where they will just say, okay, you can do the user interviews, or we can trust you on your product understanding to really make the interface try to make sense. So yeah, that's the 4 other specializations. I'll be going into more detail afterwards. Does anyone have any questions on these ones, on the high-level overviews? Okay, in that case, then I shall keep on talking and chugging along at this, as well as my water bottle. So first up.
Sorry, really quick. I did have someone DM me in the chat, but is it possible for people to do general chat? Is that for some reason not working? Like, can someone like drop like a message in general chat? Okay, cool. Thank you.
Okay. Oh, there we go. Now I can see it in the chat. Cool.
Yeah. Okay. I was just worried because it was kind of silent. I was like, wait, is it broken?
Yeah. I mean, if anyone has anyone wants me to clarify or talk about a specific domain as well, that's for example, game development. I'm not talking too much about game development because right now, because I am not the expert here. Daniel is the expert. In my mind, because I haven't done game development any work myself, but I have talked with friends who are in the industry, so I can roughly make some assumptions.
Yeah, and even if this isn't generally like, or even if this isn't specifically game development, like all of these roles are still present in game development. If not in these forms, at least something very similar. There are a few more that are more specialized, like again, tools or like game design and stuff, but these are all also important. So
cool. So in that case, then moving on to the deep dives with front-end engineering to begin. So for most of our deep dives, I'll be structuring into the 4 quadrants of what do they do, what do they know, what can they do in the future, and some of the examples of their work. Starting off with what they do. So as I mentioned with front-end engineering, they're building things that users can see and interact with. They work with web applications most commonly, and in detail, they deal with data from raw user input, as well as data, more structured data from external systems to generate visuals, as well as make changes to user input to behavior. So if you've ever been to a website where with the login system, where things have to be different between if you're logged in or not, that's state management based on the information that's given, what the user is giving, as well as what the backend and the servers are returning to make sure that the user is seeing things that only they can see. Permission systems as well are very much both a front end and back end thing, with permissions on what the user can do and see and click on. That's a lot of front end engineering. So some of the common skills that these engineers use involve app scaffolding from HTML, CSS, and JavaScript. JavaScript is a whole beast upon itself with a lot of different quirks and nuances in to really get used to. There's a lot of web frameworks that are assumed knowledge of if you say you're a front-end engineer. Usually it's one of React, Vue, or Angular, which are libraries that help you build a web application in a structured manner. Some other common skills involve search engine optimization. So making sure that your pages are being picked up by Google properly, because that's a large part of making sure that your company succeeds, as well as accessible design, because making sure that your website is usable for not only desktop users, but also mobile or screen readers and e-readers, and for colorblind users. That is very important to a front-end engineer, to be able to care about the design of the experience, while all at the same time having the technical chops to implement things that make sense for the user in the visual space. So moving on to specializations with these skills, one of the really highly specialized fields within front-end engineering is front-end infrastructure. So this is moving beyond just building things with web frameworks, apps, and websites, but working on the web frameworks themselves. Like if you're at Facebook, you're working on the React libraries, or if you're at Google, you're working on the Angular libraries. So you are then dictating how developers around the world are able to write applications using the frameworks that you are then building. That is why front-end infrastructure is very different from general infrastructure engineering, because it requires a very different skill set of being able to work within the web environment, work with concurrency with C and low-level languages to make sure things are being managed properly, as well as having a deep understanding of what each line of code really does. Usually front-end infrastructure engineers require a lot of deep algorithmic knowledge, and it's much more of a senior position that you get into after 5 to 8 years in the front-end domain or with relevant experience. Next up is desktop application engineering. As I mentioned with the Discord desktop app, there are a lot of branches within front-end engineering that also are overlapped with other fields as well, where desktop application engineering is most in the front-end domain, expertise domain, means using the web frameworks and their desktop equivalents to create applications that are suited for environments outside of just the web. An example of this is React Native or Electron, which are libraries that are similar to React that allow you to write JavaScript code that runs like a web environment, but but with different nuances and quirks specific to desktops. And that's the best. Really, it doesn't require too much of a barrier entry. It's not too high of a barrier entry. You don't really require defined expertise in front end if you want to jump into this domain and specialization itself from the get-go. Next up is graphics developer. This is a bit more of a stretch, in terms of the skill set, but it's still definitely very relevant, because for graphics developers and game engine developers, which is another related part of graphics, you need pretty specialized knowledge of rendering systems, memory management, and other tools to make your graphics more realistic and effective. An example of this in the web domain is WebGL, which is which stands for Web Graphics Library, that uses a combination of C and assembly and other net code in order to render polygons on your website, on your web page. I know, for example, there are people who have recreated Doom or Spore, or not Spore, Doom or Gario or Flash or other Flash games that use a basis of WebGL, which is very graphics heavy and require a pretty steep learning curve in terms of probably a year or so before you're really deemed like a knowledgeable expert in the field of using it daily. There's a lot of quirks and nuances that I definitely do not know because I haven't specialized in the field. field. Let's see. Field. In terms of game development, you can definitely apply these skills in order for game engine libraries and renderers as well, because a lot of the similar logic in terms of ray tracing and ray application apply in that domain. Okay. Next up is front-end security as security. Front-end security is mostly more of a security-oriented role, but just from the perspective of entry points in the front end or for where people are coming from and auditing the data ingestion sources to make sure that things are not going wrong, really. If you ever heard of like a Mozilla Firefox exploit where you can exploit where people can get Trojans or antiviruses based on viruses, front-end security is the job of front-end security is to prevent that and make sure that the browser itself is secure enough to prevent those Trojans and malware from escaping the browser and getting onto the desktop and computer environments or the mobile environments at that. Some sites might be compromised. Again, this is looking at more networks tool set. What is that? Including your JavaScript and CSS understanding to really push that to the professional level with certifications involved as well. And lastly, there's VR AR engineering, which is very much overlapped with graphics engineering. So I'm not going to go into too much. On a surface level, there's web AR, web VR pages that use OpenGL and are based on similar systems as well, which do run into similar skill sets, with about a year and a half experience to really dive deep into the intricacies and understand it. So that's the specializations. Some examples of the works are really any websites that you use, any Discord, like Discord as an app as well. In the context of game development, many use implementation of sprites and assets. There's game engine designers and asset designers as well. But a lot of if you worked with menus and scaffolding in terms of XML, that is very similar to a lot of the scaffolding you'll see on HTML and CSS and styling from the game development realm. And that's the front end dive. Any questions so far?
If we have any questions related to VR or AR, like I have no professional experience here, but I've worked with it like hobby projects. So
yeah. Same here. Got one of these lying around as well.
I have to resist the urge to ask about that.
It's the Oculus Quest 1, so it's a little bit dated now. But moving on to the backend engineering deep dive then. So what do backend engineers do? They do everything. If you don't want to decide, like kind of like what I did, and just want to do a lot of different cool things in the engineering space, and not be shackled on any one part. Backend engineering is the specialization that's not a specialization for you. It's the most flexible of all the specialties that I'm going to talk about, just because you can be assigned anywhere, and there's really more of a knowledge component to it than a specialized skill component, because the common skills and knowledge associated with the position include one main language, which might be Python, JavaScript, Java, C++, Golang, Rust, whatever it might be that you want to become an expert in, and then you can roughly understand and expand those concepts involved with being an expert in one language to another, and most companies are perfectly okay with that. There's also some database management involved. So with being able to understand and know how data is coming from and how that data is structured. So SQL, MongoDB, any kind of Cassandra, any kind of querying language, as well as a theoretical understanding of the algorithms and manipulation involved in that is key. And like I mentioned, like I listed here, a general background in algorithms, data structures is a must to really specialize in this field. this field. For example, most backend interviews will ask you some kind of programming question, challenge question, like one that you can see on LeetCode or HackerRank or so forth. So it would best be familiar with that, with those concepts in general, because you will be applying them at work. Some deeper specializations are compile engineers. So if you're using a compiled language like Python or like Go, for instance, where you create binaries, or any language requires compiler on some level. If you're not writing machine code, backend engineers, if you have a really deep love for concurrency and real-time operating systems, compile engineering is the way to go for you, because that stuff is extremely difficult. There's always looking for experts, and you will get paid big bucks. For graphics, it's also similar to that. Graphics and game engine development also very algorithms heavy, because you'll be building the physics engines, like you'll be like NVIDIA RTX. How does that work? Well, they had really good like hardware acceleration engineers working on that on the ray tracing, particularly to optimize certain calculations, as well as optimizing the calculations for different game engines like Unity or Unreal to really mesh well. And that's what you're looking at there. Again, very much a high skilled, very deep specialization, but it's very doable in terms of getting into it, because a lot of the people I've seen in that industry are very much open to sharing their knowledge. It just takes a lot of time to learn. Language engineer, very similar to compile engineer, except you're building your own programming language. Who doesn't want to be the next Guido van Rossum who Python or make the next C or Flang or something like that. There are certain cases where you actually do need the skill set to create your own extensions between, for example, Python and C on the low level and high level integrations. So that is something that backend engineers do specialize in if they choose to use that algorithmic knowledge there. The general theme with backend specializations is algorithms are applied everywhere, and you can see a very diverse set of location in the industry that they would be useful. Another one is database and data warehousing engineers, where you're looking at engineers who are especially in charge of managing data and in terms of how it's stored, how it gets queried, how it's managed, how it's backed up, and so forth. Because this is not as much of a concern when you have a hobby project for example, Among Us, before it got big, was they were running servers with no problem. But then Among Us, after it spiked, you had people having lobbies being dropped. They didn't like the multiplayer codes being exposed randomly. That was because there was no proper data warehousing to make sure that one, the networks were secure, and two, there was enough capacity to store all this information that was being onboarded. Similarly, if you're looking at Google scale, well, because a lot of these data warehousing engineers positions do come with larger companies like Google. You're looking at how do we store trillions upon trillions of user interactions per day across Android, web, Chrome, all the ways that they're tracking you. Put your tinfoil hat on, right? Next up is networks engineer, which is very related to data warehousing engineer. In when the example of Among Us I gave just now is not, the skill sets don't overlap entirely, but they are very similar in that networks engineers are similar to security engineers, except for backend specialists. They're more looking to really write net code that is more efficient and handles packets and routing in an algorithmic manner. For example, if you have Nintendo Switch Online is notorious for having bad netcode, and there are plenty of things that could be done in order to speed up how things are hosted, hosted, and just automatically make the system better by choosing a better host or preventing drop packets from affecting gameplay, or similar things, things based on architecture and algorithmic decisions that are being implemented by the engineers. Another example is Google Stadia, where they famously touted the negative latency, where they will use machine learning to predict your inputs before they happen. That is part of networks engineering plus data science plus backend engineering, all rolled up into one feature that's being outputted. And last but not least, machine learning engineering. Machine learning, huge field on its own. You do need a background not only statistics but also data structures and algorithms in order to make sure that even if you can extract the data sets to information from the data sets, you're not burning up the entire hard drive with extra junk that just from the processing you're doing, because you want to optimize it. Otherwise, it could be a difference between your program taking half an hour to 5 years. And I'm not kidding. Yeah, so examples of the work of backend engineering in general is basically anywhere that manipulates information. And when people say servers, they mean backend engineering server code, because that's in charge of the logic of handling information. Discord, League of Legends, Nintendo Online, etc. They all have various robust backend engineers to really make the logic of the application work at its core. And that's the deep dive. Any questions? Anything anyone wants me to go over? Thoughts, concerns?
I feel like I'm going to do this every time. I'm sorry, but for interesting thing about language engineer, if you are that also ties into like modding and stuff. So if you write an engine, you want to support mods, you need to have some kind of language or something to tie into that.
Oh, okay. From the comments, I feel like we're making this in the specialization. Yes, yes. This list is definitely by no means exhaustive. For backend engineers that do want to specialize into mobile engineering, it is less of a specialization than more of a lateral shift. Because the skill sets involved in mobile engineering are more similar to Frontend in that you need to learn scaffolding and different specialized libraries where you can apply your algorithmic knowledge rather than you require algorithmic knowledge from the beginning in order to really dive into mobile itself. Cool. So with that question answered, moving on to our next one. The next one of deep dive on infrastructure. If you want me to go faster or slower, I can definitely do so. Starting off with, what did they do? They build, like I mentioned earlier, they build the infrastructure that other engineers rely on. They ensure that things are scalable, resistant to failure, and reduce time spent building solutions to common problems. That's the high level. For skills that they are using, most infrastructure engineers are specialists in one primary scripting language that they're using to write deployment scripts or other things that are used to make the tools more helpful. They build more helpful. This is also where the concept of tooling engineering and comes in with DevOps or developer efficiency engineering. That's also all very similar to infrastructure, like Daniel mentioned, with tooling for game level creation and so forth. So that's where the scripting language comes in. Next up is the deployment systems, for example, Docker, Kubernetes, AWS, and other systems, where deployment systems are ways to package code that you've written so that it can be deployed or shipped to locations where other people can access them. Commonly, this means it's going to be as simple as copying the local code that you have on your computer, putting it on a different server from Amazon or a box somewhere that you own, and then exposing that to the web just by regular IP address, or it could be as complicated as having an entire orchestrated and managed deployment system involving multiple redundancies and fallbacks and backups that requires different checks to be passed before ever touching anyone's eyes. So there's a lot of intricacies that go on behind the scenes there. It requires an understanding of networks because you need to understand how people are going to be accessing the work that you put up, and also the code. Make sure the code is only accessed by people in the right locations or the right users. For example, you could be IP whitelisting, or people with from a certain building or a certain address can only access things, or MAC address for specific devices. Even there's a lot of things that go on there. And you need a deep knowledge of architecture of your systems. So some of the things that could be asked in an interview for include, what's the difference between a microservice or a monolithic structure for deploying applications? Where the answer would be a monolith. You have all your applications kind of bundled up into one server where you're hosting it from, or a microservice is where you have multiple different servers or package places. I know I'm going over a lot of the intricacies here, where each one is responsible for its own different things, own different little service or task, type of task. So that there's a lot of different pros and cons to each that I won't go over here. Deployment structures, and like config change implications of changing configs, because you will be working with configs. And also, one thing I didn't mention here that is a very common and required skill is knowledge of shells. So mostly Linux operating systems, or base systems like Mac or Linux or any distro of Linux, where you will be required to really have that understanding in order to perform maintenance and checkups on the services that you have, because most computers nowadays, when they're being used to host websites or other work, they don't have a visual interface where you can pull up like a Google Chrome tab or something like that, like your computer with Windows or Mac does. Other deeper and related specializations, because infrastructure can be a deep specialization on itself. Include DevOps, site reliability engineering, networks engineering, system architecture, security engineering. Most of these can be really bundled up into two broad categories. One specialist that deals with infrastructure as well, structure not only in terms of helping developers get things online, but also in terms of helping developers code more effectively. So that's more developer operations, or security engineering, to make sure that developers can not have to worry about the security implications of their code as much if it's in a safe environment to begin with. Or the other part of it is how to host the work that is being done securely, and making sure that they are adhering to the tenets of infrastructure engineering, which are reliable, they're scalable, and they're resistant to failure, which leans more into the site reliability engineering, networks engineering, and systems architecture roles. Both of these categories of specializations require similar skill sets in one scripting language, deep understanding of networks, potentially more algorithmic focus, and being a technology specialist on the tools that you are using. That's really important for infrastructure engineering, because one wrong config change could be the difference between you securing all your data and you opening up for all the world to see. Some examples of the work that you have for infrastructure engineering include all websites that you can see must live somewhere, anywhere that requires cross-system communication, be it from your phone to the desktop with AirDrop, or from your notification system for any applications as well. And any netcode in general, switch online, multiplayer games, web browser is a form of it. Any real-time communications, that's all infrastructure at its core or being visible to the user. Yeah, other examples in specializations, specialization works like tool engineering, developer efficiency. It could be building administrative tools for our developers to use and monitor the code to make sure there's no logical flaws or errors happening, or it could be level designers like Daniel mentioned, and that's the infrastructure deep dive. Questions, comments, concerns? What level of education would you need for this? You can. I've seen infrastructure engineers and by extension backend engineers, front-end engineers, all kind of engineers without a formal, I'll call it, university degree. They've just had experience and really worked hard in order to get to the positions they were. Usually these positions are hiring for students with a bachelor's degree or equivalent in terms of experience. But once you have like a year experience, they don't really care about your degree nearly as much, unless it's a company that specifically requires it for a master's or PhD like research level positions. For some of these deeper dives, you do, rather than requiring education in terms of degrees, you require specialization certifications that can be taken from different security providers or just have more providers. For example, one of the most the strongest engineers that I've personally known was someone who dropped out of high school to work on his own startup, and I met him working at Uber, and he was one of the most senior engineers on the team because he had so much experience with infrastructure just by doing things by practice rather than learning things in class. Yeah, any other questions so far before I move on?
Just kind of amusing note on that. I think Steve Jobs was a school, like a college dropout or something, if I remember correctly.
Bill Gates was a dropout.
Oh, maybe it was Bill Gates, or maybe it was, I don't know. I know at least one of them was.
Mm-hmm. Bill Gates, Mark Zuckerberg, a lot of the big boys in tech come from dropouts. But yeah. Can a certification work as a substitute for a degree? A lot of the times, yes, depending on what kind of systems you're working with. For example, I'm personally more familiar with the Cisco set of certifications, just because I've had exposure to it from a lot of the conferences I've been to. If you have a CCNA or a CCRE, which are Cisco certified networking assistant or networking executive or so forth, which by themselves, the highest level might take like years of practice and study. People will just not bat an eye if you don't have a degree. Like you have a certification. Cisco themselves is certified that you know their networks to the point where they will toss millions of dollars at you without issue. And that's more of an infrastructure specific. For engineering in general, experience. The reason why companies want to see degrees is because they want an indicator that you can learn and be successful in providing business value to the company, and a degree is an indirect way of screening for that. However, the better way of screening for that is direct experience. So if you can find an internship or work experience, you get your foot in the door, you're pretty much good. Yeah. So moving on, I think we're hitting close to the hour mark, which is I did not expect me to take this long, but I still have a decent amount of chunk left. The next up is a deep dive on data science, after which I think I need to take a small break in order to refill my water, otherwise my throat might die. the data science deep dive in starting with what do they do? Data science is a generous role for finding valuable insights from collected data. So they're not collecting the data, but they're making use of it. So, they can do things from data pipelines, data modeling, visualizations, and other ad hoc investigations based on their knowledge of math and statistics and the answers that are important at the time. The common skills here are specific languages that are designed for scientific computing, including Python, MATLAB, and R. MATLAB and R are special scientific languages, computing languages that have toolkits associated with them for data science. Whereas Python, you require some libraries and data processing functions like NumPy, scikit-learn, or equivalents like pandas, TensorFlow, if you're doing machine learning. It requires an understanding of data architecture in terms of how your data is being stored in order to figure out the best way of extracting the information and manipulating it in ways that are extracted. You need a pretty strong knowledge of math and stats to really thrive. And a traditional degree in terms of mathematics or engineering definitely will serve you well. Here, unless you have experience. For a lot of the higher level positions, like senior data scientists or data scientists, you might even be looking at a requirement for masters or PhDs. That isn't uncommon for this domain in particular. Some deeper specializations here include machine learning engineers, data mining engineers, system architects, and data warehousing, data visualizations, and data communications experts, as well as cybersecurity data analysis. Most of these are based on the foundation of your data science skill set of math and stats, and being able to extract value from information transfers well to making models that can find information in the right ways, or mining the data itself for more insights based on machine learning engineer and data mining engineer. It could also be involved things like your understanding of how to manipulate data in proper ways would lead you to be a better systems architect and data warehouse engineer, because you know how to practically manage the data in ways that will be useful otherwise for other engineers to use down the line. The visualization, people want communicators. Communicators are great, are great. English class is very important, and having an understanding of being a great technical communicator is something that companies are very much in demand for, are actually looking for. For example, I know within a lot of different companies, especially larger ones, they run specific technical communications workshops, as well as technical blog post writing in classes, just because they want more engineers to be able to showcase their work in explainable ways, to be a face for the company in terms of why these systems we're building are important and why you should work for us. Next up, and lastly, cybersecurity data analysis is data analysis. There's a lot of complex patterns that can't be seen just from the visual inspection of the logs. You need to be able to automate that process of finding insights in what kind of ways your security is being touched, and seeing and dynamically respond to that without a human always being present. And building machine learning models or an analysis models using regression for those logs is a domain upon itself that is more leading upon the security front. Examples of the work include search engine recommendations, fraud detection systems is really huge for banking and fintech, like 3D model generation and frame extraction. For example, if you ever use an iPhone with emojis, that's data science being there in order to learn what your facial structure is and applying those animations onto your face, or being able to use 3D tracking software to find like the right data points and which ones are noise when generating 3D models from physically scanned objects. And then also like For video games, toxicity analysis and reporting systems. If you ever had League of Legends automatically report, you report somebody and they automatically get feedback, which doesn't happen usually, but I wish it did. Wish it did. A lot of data science goes into that, as well as the ranking and matchmaking systems. And that is a deep dive. Any questions on this? If anyone has any questions, please put in the chat. I'm going to fill my water bottle really, really quickly. I'll be back in like less under a minute.
Yeah, also be right back to it. That wasn't, on one hand, like I'm curious to know what y'all are like. Personally, I'm very interested by this. But like also, yeah, I do know it's going a little long. So if you do need to leave, or like if you have a question that's unrelated to what's being talked about at the moment, like feel free to ask if you want to ask it before you have to leave. Like that's fine too. So I mean, I assume Kyle can probably answer that pretty well, but my guess is probably that like in data structures, that's where they talk about trees and all that stuff. Often you're asked in the like in interviews, like do a tree, do a tree traversal, whatever. If you've just covered data structures, that's all going to be fresh. Like I know that I'm going to have to read that. So yeah, I'll let Kyle answer that one.
Okay, I am back. Thank you for waiting. I am back with water, so my throat is no longer parched. Going into the questions. First off, I hear that most say to sign up for internships the moment we finish data structures. Why is that? So signing up for internships the moment you finish data structures is because a lot of internships usually require a programming interview to test your knowledge, whether it might be indicative or not indicative indicative of your skill level. And that's usually in the form of a like a elite code or a hacker rank theme challenge. So for example, one of the questions I've gotten in the past while I was interviewing for I believe it was Google was given a array of arrays of variable depth. Can you flatten out arrays of variable depth with a single multiple integers in each list, each array, different lengths, flatten it out to return a common array. So that's not really indicative of your programming skills, but is indicative of your algorithmic management skills. So data structures algorithms are very helpful in terms of giving you the skill set you need to really go further with those questions and practice and giving the tools to solve them yourself. Let's see.
And if you're wondering, I just let people, like, since we're at around like the hour mark, I was just saying for people who do need to leave, if they have questions that might be unrelated to what we're talking about at the moment, they're more than welcome to ask before they have to leave. So
for sure, I will also be part of your Discord. Discord is answering questions. If anyone wants to ping me. I think I'm just at Qile on the Discord, so I can. If anyone has questions afterwards, feel free to ping me on the CPP Game Development Club Discord. Other general question on why did I start the company? Mostly it was just a matter of circumstance that happened to turn out pretty well. In terms of background, my school, Waterloo, has a pretty well-established co-op program where a lot of universities come to recruit from our school, and as a result of that, I had the chance to do 6 different internships over the course of my undergraduate career. So 2 full years of work experience by the time I had graduated, and a lot of my friends from different schools really wanted to were gunning for Waterloo. students because they wanted that kind of structure. And it didn't really. It felt really weird that we had it. And other students just were not getting these opportunities that were being given to specific universities. The other part of it is during August, during the middle of the pandemic, there were a lot of startups that we noticed were hiring because of all of the reimbursements and tax credits being given by the governments of various countries. Even though large companies were shutting down hiring, and because these startups were trying to hire, but they didn't have the capability to market themselves as well, they were just reaching out to all their friends. And we have myself and my co-founders, we happen to be pretty well connected in the space just because of all the previous ventures that we've done and been involved in. So we ended up acting as a connector, a bridging point between our friends who were looking for internships and these startups that are networks that wanted interns, and we just kind of grew out of that into, hey, why don't you pay us for these interns, because students should not be paying for our internships. And it kind of just grew from there and became official last October. Okay, reading the last comment here. Note, it's all fresh and minimum to get an internship is my heart. I agree that data structures, having fresh data structures, is very important for the interview process. Although some startups, like smaller companies, will do a practical programming project challenge rather than being on doing an algorithms challenge. So it's not always necessary. It's also that you don't need to know the algorithms by heart. You just need to be able to solve the problem enough to convince the employer that you roughly know what you're doing. Because I definitely have gotten in opportunities where I didn't really know what I was doing. The other thing about this is that having the tools in your tool set is the most important thing. So you can also learn these on your own. For example, I highly recommend the book called Cracking the Coding Interview, which really gave me the skills I needed to jumpstart my career in solving programming challenges for internships when I was in first year. And yeah, so with that being said, I think it's about time we moved on to the next deep dive slide, which is mobile engineering. So similar to front-end engineering, mobile engineering deals with a lot of what you're seeing, except on a mobile structure, and their specialized specific platforms. They work on implementing UIs traditionally non-web platforms. Although there are engineers that work exclusively on mobile versions of websites, or embedded websites within mobile apps, which is like a domain itself. It's also, you're working with ingesting user input and structured data from backend systems to create these programmatic interfaces. Some of the common skills for iOS and Android are Swift and Objective-C for iOS, most commonly Swift now. Objective-C is commonly kind of a sunset unless you're using it for really niche things, or Java and Kotlin for Android. Java and Kotlin sync the dichotomy with Objective-C and Swift. Java is more for legacy stuff or like special niche applications, because Android is built on Java, but Kotlin is more up and coming and it's a lot nicer to use in general. You can also use JavaScript for React Native, which allows you to build mobile apps using a web kind of like framework, and C# with a Unity or C++ with Unreal Engine if you're looking to build a game for mobile as well. You kind of need, for mobile, you need to understand the application lifecycle and rendering engines and memory management, because you'll be dealing with a lot with, okay, what happens when a user exits my app? Do I put it to sleep? Do I put it to stop? Do I stop this process, or do I need to make them re-authenticate themselves, and so forth. Or if I go from one screen to another, what happens to the other processes that this screen kicked off? So those are mostly, there's a lot of overlap between the life cycles for a lot for iOS, Android that are mostly transferable, but there is a lot of room for domain expertise on specific subsystems as well. And then some deeper and related specializations include desktop application engineering, similar to what Frontend. So I'm not going to go too much into it. Graphics engineering, especially for if you're doing development with C# in Unity or C++ Unreal with other game engines that allow you to target multiple different kinds of devices. Graphics are a core component of that, and it deals with a lot more low-level systems. VR, AR engineering, Google Cardboard comes to mind. Any other phone-based virtual reality or AR kit for the iPhone, pretty sweet stuff. Stuff is embedded within the mobile toolkit or their platforms. And then platform security. Mobile security is huge. People are going to a lot of different websites, and they need to be contained beyond just trusting the developer to a trusted developer. It can also be plus security in terms of building the iOS operating system itself. For example, Apple has recently created the privacy tracker opt-in stuff, which Facebook is really mad about. That's platform security at its core being implemented directly in your real life. Examples of work. Any mobile game application, and a lot of desktop apps like Battle.net or the Battle.net client or the League of Legends client require custom engineering that is more similar to the to the mobile engineering scaffolding, because it combines a mixture of more graphics engineering and than just structured scaffolding like what happens in web with Frontend. I guess technically they're based on how you want to define it. Frontend and all the engineering, basically very similar things, but there's enough of a difference in terms of how many people specialize in Frontend and mobile each that I wanted to really differentiate them. And then Unity, Unreal, and other game engine work can be cross-compiled to mobile systems for mobile games, or you could be using that skill set for desktop games or whatever you want to be doing as well. So that's the overview. Any questions? Any questions on mobile engineering? Dart. Yes, I knew. I knew I was forgetting something. I have not touched mobile engineering in a while, so it is definitely rusty for me. Dart and Flutter, thank you for bringing that up. I can't say I'm not too familiar with that either. Okay. With that being said, I think next on the list is security engineering. Oh, and the slide is a little bit off-centered. Oh well. So what do security engineers do? They discover and fix vulnerabilities in applications that could lead to breaches of information security. It's unique within the commonly found roles of it being really a specialist career that's not as transferable, because if you're working with mobile engineering, front-end engineering, infrastructure engineering, you're using a lot of skill sets that really overlap with each other with like back-end engineering, front-end engineering. Whereas security, you're specializing very hard, very fast on the system rather than on the knowledge and skill set of, in general that you'll be working with for other engineering practices. Like I said earlier, there's a high barrier for entry, but there's an absurd demand for senior candidates. Like good security consultants, millions of dollars per year on top. If you can get you can like win the DEF CON hackathon, you're up there, and you can definitely get started as soon as you want to, based on just picking up a system that you want to become an expert in. So common skills in security engineering is, again, one scripting language for building out your networks and your general script work for automating your processes, because you can't do everything as a human. Bash, again, similar to infrastructure engineering, you'll be working a lot with the shells and terminals because there's no visual interface. you need a very strong networks understanding, and you need a lot of system certifications. And if you want to be a consultant, I will also look into social engineering as well, because at the core of things, the most vulnerable part of any system, no matter how well engineered it is a human who has to operate it. So so there's a lot of stories about, like, for example, Mr. Robot. Mr. Robot is a TV show that was pretty famous, pretty hot a while ago, about security researcher or security expert who's on the black hat side or on the white hat side. Some deeper and light specializations: systems architecture, data warehousing, penetration tester, security auditor, networks engineer, infrastructure engineering, everything related to the systems that are being used and used to host the work that is being done on the internet needs security. And as a result, you're going to be touching a lot of different places in regards to how they're setting up configuration and configuring the networks that they're working with. So you could be a penetration tester or a security auditor for the security auditor on black hat or white hat. Hopefully white hat for you, because those bounties are pretty nice. And I'm not condoning anything here. Data warehousing, because a lot of the work of security involves keeping data safe, you'll have to know a lot about how data is stored in order to how to best protect it. So you could be going into that field. System architecture, you're working with how things can go wrong. So you have to know how things are built right first. Networks engineer, similar system architecture, and infrastructure engineer, very similar on the same line as well, in that to be a security engineer, you need to be able to figure out what can go wrong and fix it. But in order to know what can go wrong, you have to know what's building and how it's been done right. In terms of other skill sets and quirks about the profession, is that security is very strange in that you need to become basically a domain and system expert. And the more systems you are an expert in, the more trends you can see in the overall industry, which leads to be senior, rather than some of the other engineers where you can start off from a variety of different spaces and bounce around, but still constantly be rising up. Whereas in security, you kind of just need to dig down deep with that certification level before you can really expand out. Otherwise, your experience is not nearly as transferable or valuable between systems. Examples of work, there's really few examples of security going right, but there's a lot of them going wrong. Some examples of being right include like any of the bounty hunting, bug testing and stuff and so forth. But examples of going wrong include like the Equifax, Sony breach, LinkedIn hack. Any kind of hack, security is involved, and security failings are involved, and lack of management configuration of systems to be secure, to be properly maintained. Some of the practices that you'll be doing involve building the safety nets for codes to run in more isolated environments, so that engineers don't have to worry about the direct security implications of people being able to access the code, or so that it's not vulnerable from the get-go. And that's the security engineering deep dive. Any questions for this one? Several questions. Go for it. You can put them in. I can answer them at the Q&A at the end, because we're probably getting close to that as well. And I can keep on moving along. Cool. And now, off for engineering train for a little while, we are in the product management space now. So like I said, product management can be technical or non-technical, depending on what kind of background you have. It is the voice of the customer and deciding what to build and when to build it. You work with business, engineering, and design to see things through, and it varies a lot based on the product stage and the company's size. So there's really a lot of different skills that are associated with it that are a lot more soft skills than hard skills also you really need. But the core components of it is a product level thought process, So so otherwise known as systems thinking. What that means is you need to be a successful product manager, you need to be able to consider problems from multiple domains. For example, domains, and your organization is key. And because you're dealing with the feedback from not only the customers but also multiple different departments within design, sales, engineering, management, marketing, and so forth within the company, strong interpersonal skills are very important. An example of a product management at work is, for example, let's say with Amazon. I can guarantee you for sure that their homepage is very optimized for every dollar they can get out of the customer. And so let's say if a product manager wants to change a button or a promoted product, promotions from the top to be a little bit to the side or left, they have to think about, okay, how is design going to implement this? Cool. How is that design change going to be built? How will sales promote it to our corporate partners to make sure they're not getting shafted in terms of what products being promoted? How are our marketers going to be marketing the change, or are they not going to be marketing the change in order to better serve our business? And lastly, most importantly, how will the user be affected by this? That's the example of the entire thought process that you have to go through, minus all the details. Deeper and related specializations. There's really two here, which is one, project management, which is not product management, because product management deals with the direction the product is going to go, whereas project management involves managing people to make sure that they are on track and have all the tasks they need and broken down or succeed. Product managers can do project management responsibilities and have those responsibilities in terms of ensuring their team is working effectively. However, a project manager is much more difficult for a project manager to become a product manager, because that's systems thinking is key to success. And then really, because once you have that systems thinking, anything in the management sphere just becomes yours to explore. Because on a higher level, every employee of a company should be thinking about what drives value for that organization. And if you can master that skill, you are going to be in a position where you are influencing the company in better ways than people who aren't thinking about that. So anyone in management, feel free to hop onto that. Examples of work include task breakdowns, goal setting, performance and progress tracking, setting performance indicators. For example, in game dev, game directors are basically product managers on a game level, because they're directing the vision of the product. And really, anything goes. Anything built has had a vision that needs to be adhered to, and there's lots of stakeholders that need to be addressed all the time. So yeah, that's the product management overview. Actually, one thing I mentioned, the strongest product manager I've seen don't hop into PM directly. Rather, they have a background in sales or engineering or design or marketing that they can draw from for experiences in order to make them more effective from one particular viewpoint. And that is the overview. Does anyone have questions?
Just from my understanding of how things work with game industry, usually you'd just to make it clear, this is not the same thing as design, where usually the designers are or the game designers are we want to do these things, and then the product managers are the ones who are well, we don't have time to implement, massive world, we got to scale it down. They're the people who are realistic, basically.
Yeah, you have to be realistic to have this job. Because you have to keep in mind not only the vision but also limitations that you're currently dealing with. Cool. Next up is UI UX design. So this is the last deep dive I will be doing before I go into the other considerations. The first one is, what do designers do? UI UX designers do? They create the interface for the product for engineers to implement. They ideate on not only the interface but the entire experience from start to finish. And really, it varies very heavily depending on the company structure. So some common skills involved in UI UX design is, because UI stands for user interface and UX stands for user experience, you need a really strong understanding of the user to be designing interfaces that make for a great experience that drive value to your company. I want to put this and make it very clear that artistic skills for UI UX design are very much optional. You don't need to be a great artist in the traditional sense in order to be a great UI UX designer in the tech space, because there's a lot more to it than just making things look nice. Some of the tools that they use involve mock-up creation tools like Figma, Sketch, or Adobe Illustrator. And something I didn't mention here is you need to be able to build on your understanding of the user to extract value in terms of directions you should be going into design. For example, if a lot of the users can't find a way to sign up, maybe the sign up button probably should be a lot larger or more apparent, or follow you along if that's something that you really want to happen. Or you might not want people to sign up at all, so you just hide the button entirely. That's part of the UI designer's job. Deeper related specializations, user researcher, because you need to understand the user very deeply in UI UX design. You need to be able to do research on what users want, and that's the specialization in itself. It's a related specialization because you can hop into that immediately. You don't need to be a designer first in order to get there. But it's the skill sets are definitely help. You can be a brand specialist in terms of designing the contract basis for different brands, in terms of designing their experience flows. It could also be on a strictly UI point where you would be then an assets designer for just UI, which would require a lot more pure artistic skill. Examples of work, really everywhere. Anything you see, all the assets for games come from UI design on some level, because visual VFX designer, VFX artists and like visual effects models designers also follow roughly into this category, even though the skill sets are not are more specialized. Like game model designers and artists, that's a very specialized skill set within like being able to do 3D modeling and make it perform well and rig the systems well, where it makes sense to be a specialist position within itself. And yeah, it's definitely. Any questions there or comments? Cool. In that case, then, that is all of the deep dives. Other niches to consider. Just gonna do a quick run down of these. Developer evangelist. Basically, any developer evangelist. Basically, a developer who is in charge of communicating with other developers for companies. They are mostly commonly involved in being a part of conferences, hosting workshops, kind of like what I'm doing right now, workshops, and presenting to other companies to make sure companies and working with developers and solving technical issues on the ground level, because they can be both a pitcher as well as a technical engineer. Next up, sales engineering, basically someone who does the legwork of working directly with customers on sales prospects, and then having the engineering chops to answer any technical questions that come up during the implementation process. Also, answering technically challenging questions from other engineers to evaluate the feasibility of integrating systems if you're selling, for example, B2B software. Growth engineering is more of a generalist role within the engineering space, where you would be given leeway to run experiments of your own and building those experiments out and seeing how that affects the core value metrics of your company. For example, a growth engineer could be in charge, could have an idea to build a notification system for the backend, and then update the frequency of notifications from once per week to once per day, and then they would test that in practice and then iterate on that based on whatever they think is right. So that's a bit more of a generalist engineering. It's just like similar to backend, but more for growth in terms of dealing with users and having users in mind. Blockchain engineering, if you heard of Bitcoin, it got rich, lucky you. Blockchain engineering is a lot of that. It deals with similar skills as networks engineering and backend engineering, but it's very, very specialized in terms of what kind of concepts they're dealing with. So it's also pretty distinct. You would be dealing with a lot of Golang or Rust and concurrency, as well as smart contracts on Solidity for Ethereum, Ethereum in particular. Hardware engineering, embedded systems. This is a bit harder now during the age of remote times, but very much a more practical application engineering skills. If you have circuits knowledge, electronics knowledge, and want to deal with the thing that really scares me, by all means, it is absolutely a fantastic engineering space. Full stack engineering basically is front end, back end. You'll see this more as a description in startups who don't really have the manpower to really hire specialists for both front end, full stack, front end, and back end. So they ask for full stack people who have skill sets in both. And it's really okay. It's really more of a small company role. Software consultants. You can do any of the roles I mentioned before, except as a consultant, where you have to be in charge of managing your own contracts and your own clients, and you get paid a lot more per hour usually for it, or per contract for it, but you have a lot more downtime where you don't get paid, and you have to work with no pay yourself in order to find more contracts. So it really balances out until you get really to the top of the game. And then management versus specialist. For each of these career paths that I mentioned here, you could either become a manager, where you start managing developers and climb the corporate ladder, or you can become a specialist in terms of your skill set to really grow as a technically skilled employee. Both have their own merits. If you really like hacking on things, even if you want to be a specialist in the future, a lot of companies will try and push you toward more of the management role, but you can also push back and become more of a tech lead or consultant, where you can do all the technical specialties that you want. And also, just throwing the last consideration in here, which is startups versus large companies. General rundown: large companies, they want domain expertise. They want to raise everyone up to a certain level, and they want the best people they can get for every position, and they offer fantastic perks at large companies for full-time staff. Like while I was Uber, it was like free snacks all day, free snacks from whatever you want. Unlimited paid time off, although that's pretty much a scam. Like paid work vacations, work whenever, flexible hours for some employees. Like I know Google and Facebook have like video game arcades or like massage rooms, and they can like yoga classes can be a part of during the day. It's like they will get everything. They will throw everything in the kitchen sink at you in order to get you to stay, because the work there, it really, for me at least, it felt like being a cog in the machine, and it really didn't vibe with me after a while. For startups, on the other hand, they require flexibility to survive. So they're looking for flexible people with the ability to learn with diverse skill sets. You need a product and whole picture focus for team members. So if you're an engineer, you can't just be heads down on the code all the time. You need to think about how the features you're implementing are affecting the end customer and bringing value. Like everybody needs to understand more than just their own part. They're definitely lacking on a lot of perks, because smaller companies like startups don't have the capacity to offer those things. But in exchange, you get a much faster paced environment where things don't take weeks to get approved, and you're constantly learning more things. For me, I really enjoyed having startup for my first few experiences in internships in particular, and later went back to it because it helped me learn a lot faster. So that is the rundown. I know I went over a lot. Sorry for the bad time estimate, but thank you for listening. Really appreciate you guys sticking around the entire time, and hopefully this was helpful or interesting, or yell at me if it wasn't.
Yeah,
Okay.
thank you very much. I wish the saddest thing about being online is that clapping doesn't really work.
It's okay. It's okay. I can imagine the audience in their underpants clapping right now.
Yeah. Or no. Everyone do your. Can we have some pogs in the chat?
Appreciate
we got a
it.
bog.
Appreciate it. Okay. Bring back the pog champ. Oh man. Yeah. I guess summarizing things. One more shill. All the opportunities I mentioned are examples of jobs that we do have available for application for interns on techintern.io coming on April. So sign up as soon as you can, and we'll give you notice when we're opening up applications. One click for everything, fully free for students. Everything is paid in terms of opportunities. Okay, that's the shill. Questions ahoy. If anyone has questions, feel free.
Yeah, also did I did put the link in the chat. I did mean to I will also put this in the Discord. I meant to do it sooner, but I was more like just need to let people know that this talk is actually happening, and then I like
no problem. Appreciate the helpful listen to the shill. If you have any friends who are looking for internships too, please spread the word. More students means we can get more companies on board. Okay. I guess first question I can see is, what do you mean that paid time off is a scam? I don't mean paid time off is a scam. Paid time off is fantastic. I love it. I love it to death. I mean unlimited paid time off is a scam. Unlimited PTO is a scam unless there are mandated minimum requirements for employees must take X days off. Because usually when a company offers unlimited paid time off, it's in the hopes that peer pressure will get employees to not take it at all, because it's always there, but there's more time. I could be taking this at a more opportune moment. So, like, I know there's been studies done. For example, if at large tech companies, a lot of the time when there's unlimited PTO being offered, all the people just don't take it. Just work the entire year and just knowing they have unlimited PTO, but they end up burning out eventually because they don't feel the urgency and the need to take the time off. And a lot of times when unlimited PTO is offered as well, it requires direct approval by your manager. And that means that if you're on a team that's really a workaholic team, you might just get fucked in terms of not being able to take time off at all. It's really much like how it could be done right is if companies enforce mandatory PTO minimums, and there's a culture of taking time off, and that kind of forces the employees to really think about, I have time off that I should be taking for my own well-being and health on a per year basis, and that's why I feel strongly about that subject.
And that's actually very, very relevant to the sphere of game development, because there have been cases where like I know that Blizzard's been criticized for this in other big studios where they're just like, you need to work like crunch all the time basically to get stuff made. And a lot of people, like, there's been cases of people who just go in and then like after 5 years they burn out, they switch to another sector of development. It is a big deal. And it's just especially tough with games because it's so competitive. There's
CD Project Red.
Yeah, that's extra relevant. So thank you,
Yeah.
yes, for that question.
Yeah, thank you for the question. Let's see. Also, like, there's also like the factor of work culture in different areas. Like in China, 996 is a thing. 9 a.m. to 9 p.m. 6 days a week. Absolute hell. Don't do it. Don't do it to yourself. Okay. So there's a big comment cluster here. Let me just take some time to read over this. So reading from the first one, considering a large barrier to entry, how does one get started in the security engineering field? Start with certifications. First off, take a networks course, either online or practically. Try and reach out to experts if you can, and like look for publicly available guides on where to get started. I have to admit that I'm not a security engineer by practice, so I don't have the most. I can't say anything directly about the pathway in, but from friends who have, their ways in have always been through the certification realm, as well as getting connected directly with the engineering managers of security-based teams, as well as large companies, more large companies that had the leeway and bandwidth to act as a safety net if a junior security engineer makes a mistake. For Cisco, like Cisco is certified for CCNA, and like they have a bunch of certifications on the website. That's a great place to start. There's also like a bunch of like penetration testing, like white hat hacking, the like ethics courses that you might want to look into as well, in terms of what is good to do, what is never touch this with a 10-foot long pole. So because that's a very fine line of balance in the security realm when you could be potentially dealing with people's information and livelihoods. System certifications are sought after in the security engineering field. I can't comment on this, unfortunately. I don't have the expertise. I would look up the large security certifications on the different systems providers websites. I know Red Hat, who is one of the is one of the providers of their own Linux distro, does have security engineering knowledge to available to share, as well as a lot of talks from DEF CON. DEFCON is a hacking focused conference that basically they say that you can't turn on your phone at all, even without Wi-Fi, otherwise you'll get hacked. Is the home of security research specialists, and they will help. They can definitely point you in the right direction. Other places to go, you can reach out to direct researchers in the industry and ask them, hey, can I read your paper? Because all the papers in general academia are published by companies. And the companies make money when the papers are being accessed, but the researchers don't. So if you research them directly, they're happy to share. That could be an in to having a connection in the industry. Let's see, systems programming and systems programming. I'm not sure what you mean by systems programming here. If you mean by systems architecture and you're designing like diagrams and diagramming the architecture solutions that that your product is going to be using, that is always in demand, but that is always done by senior engineers with a lot of experience in terms of what goes right and what goes wrong. They are the ones. They're the ones that make, or if they're short-staffed, like the junior engineer who is starting the company, or whatever it is that you can get access to. The more experience, the better in general. For systems architecture and systems programming. Okay, so OS development in mind is what you're saying now. Operating systems is I'm personally not aware of any positions where OS development is being actively recruited for beyond the scope of very specialized domain experts. For example, people who are in Apple doing core iOS engineering, or people who are at Google doing the work on Chrome or Android. That stuff requires many years of experience in being domain expert in in concurrency and operating systems first. Mostly low level programming is what you're looking for in order to really be a specialist there. It's definitely in demand, but those positions are very rarely, like they're always recruiting, but they're very stringent on who they're actually going to take. Although I know for a lot of desktop apps, they look for concurrency related specializations. For example, League of Legends client is shit. They're looking for concurrency engineers to make that desktop app better all the time. That's one way to get to that level of expertise where you can get you can do more operating systems engineering. Let's see. How many startups have you seen get bought out by large corporations? How do employees transfer over to a larger company? Are buyouts a particularly common outcome? Yes and no at the same time. Something like 70% of startups don't end up making an exit, be it being bought out by a large company or going public. Those are the two major ones. The other 20% get bought out for mediocre. The other 20% get bought out for mediocre buyouts a lot of times, or IPO for a zombie state and just don't really do much. And the last 10% that are actually get really zoomed up, assuming those startup has lived for a year when you're making that breakdown so far. So we're not exactly there yet, but hopefully we're part of the very nice little batch. In terms of being bought out and basically and being transferred over. Being transferred over depends on the vesting of shares and how much ownership you have as a company as an early employee or a sharp employee, and it's a very different process on each buyout. So there are, like, I can go into this a lot, but I don't think it's totally relevant here. But basically, there's different share classifications on who gets paid out when. Sometimes it's the founders get paid out first, sometimes the investors get paid out first, sometimes the employees get nothing, depending on how the shares and money comes in. So be very aware of what you're signing in terms of ownership of the company if you are going to join it full time with equity early. In your opinion, what position has the most future? Really, anywhere in tech, you can't really go too wrong. I know there's been a lot of talk about, like, outsourcing developers. Development is going to get like commoditized and automated. There's trends about that, but I can go into outsourcing problems a lot because I've worked with outsourced developers personally, like a decent amount. It ain't pretty. And if it does happen, it'll happen to all of the specializations in general as a group. It's not going to be like one will have better prospects than the other. It's going to have, there's specialists in all domains. So you can't really go wrong with any of these. I think that if you want to be flexible, the most flexible, backend engineering is like the most flexible transferable skill set, because you'll just have a strong technical understanding of the systems you're working with in general, rather than specializing in any particular field. So that would be the most flexible answer there, although flexibility by itself has a lot of trade-offs. Let's see. I think that's all the questions I have here. If anyone else has anything else, feel free to shoot.
I have a question, just kind of as like something that at least personally I've struggled with when I was first like when I first went to school. My original thought was just like, I'm going to go into game development without really thinking much on like where I'd specifically like to go. And then when I first learned that, there's specializations I need to worry about, then, I had for a while this thing of just like, I don't really know which one I want to commit to. So for that, like, do you have any advice for people like that, where they're just sort of like getting started and they're not really sure which direction to look at?
Yeah, totally. Like when I was getting out of I was fortunate when I was in high school that I just kind of like got started with front-end development and building websites that are like static HTML, CSS with no JavaScript. And one of my teachers was willing to pay me for a website, which was which kind of got me in the foot of thinking about development. And I think the best advice I have for really younger me, because I don't want to preach, is just build things. Build things that are interested in. Like if you're interested in something, you'll be more likely to actually take time to build it than otherwise. And then in practice, uh, actually don't just build things. Yes, you should be building things, yes, but you should also be putting it in front of people to really make sure that the work you're doing is useful. Because at the end of the day, like a company is not hiring a developer for the sake of, oh, I want to put their skills in a trophy case and say we have the developer. Unless you're like very very specialized already. Um, they're hiring you as a developer or a product manager or a designer to generate value for the business. So if you're trying to make products and projects and make work that provides value to people, be it your friends or random people on the internet or just for shits and giggles, that entire process is invaluable for exploring all the different related aspects that you might be involved with as a specialty. And I think really, I really encourage anyone trying to considering the options to just think about an idea, build it out, and get somebody to use it. And that will give you a lot more information about yourself and what you want to specialize in than any talk will ever will.
Yeah, I see. Yeah, thank you. Yeah, that's like that sounds like after like at this point, like if I were to answer that question at this point, I'd give almost like a kind of similar thing of just like, yeah, build things. But it does help to know that like I, that's not just me like randomly like, I just like to build things. It's just interesting because like I've like for myself I've found like, oh, I tend to spend more time just like struggling with this thing is a bad to like this is inefficient, let me just build a better tool. And I find myself building a lot of tools now, and so like that's now probably where I'm going to be going more into is like building, some closer to like the infrastructure stuff. But I didn't know that going in. And at first I was like, I just want to design stuff, but like that's pretty vague and like,
Yeah, like for me, I had a similar thought where like I realized that during all my development career, it was more of like I didn't really care what I was building. I didn't really care about making things 10 seconds faster or like more efficient. I care about like what people thought about the things I was building. Like, did it make them happy? Did it make them happy? Could I see that they were happy with the things I was building? So it ended up with me doing more startups where I can see that direct impact, and also just work on more product level stuff rather than just continue to stay as a developer.
Yeah, I see.
Yeah. Okay, well, I think I went a full hour over. I think that there are no more questions trickling in. If anyone has more questions, feel free to join our Discord community where it's like where I have where I'm always online because use also on the work chat, or email me at Qile@techintern.io.
And thank you so much for coming to us and asking if like it was Kyle who came to us and asked if there's any way he could help, and so we went from there basically. Funny story with that, but I'm not really going to get into that. You know what I'm talking about, Kyle. So yeah, thank you very much for approaching us in the first place, and it's been a very great talk in my opinion, and I think it sounds like the chat agrees too.
No problem.
So yeah, thank you very much for taking the time to for all this. Yeah.
Well, thank you for having me. It's been pretty interesting doing the talk and getting things prepared. I have a better sense of how much time it takes to do these things now. If you want me to come back, I'd love to come back again. Like I've done other talks in the past on like how to write resumes, like how to interview some other things. If you are looking for other things like that, things like that. And also in general, if you do know of anybody looking for internships or new grad positions that are technical, please send them my way. Really want to share the opportunities with anyone who might find them useful.
Okay. One last quick question.
Oh, one last question. Cracking the coding interview.
Yes. I know of this book.
By Gail Lockman McDowell.
There's actually even just a website here for it.
Yeah. It helps in the books that knows the website.
It's I'm amused. Like I just Google it and that's what comes up first. It's like, I was expecting Amazon, but yeah. Okay.
All right. In that case, then I think I will hop off now. It was nice meeting you, Daniel, and thank you everybody for hopping along.
Yeah, thank you for coming, and also thank everyone who joined us today. Again, this will all be posted. So yes, hope you all have a good day. And for everyone,
slide link is also out in the open. Let me just post that in the chat here. Anyone wants to take a look at it later.
Yeah, and we'll be putting that on the Discord too. Yeah, and also for everyone who's currently going through midterms, best of luck to you. I know I still have a couple more coming up.
Good luck.
So, good luck, everybody.
All right. Bye-bye.
Okay. Goodbye. Thank you.